Let's go through LeetCode 368, largest divisible subset. For this question, it gives us the integer nums, and let's find the largest divisible subset. So you say that if every pair answer I and j, right? If, for example, answer I mod answer j equals 0, or answer j mod answer I equals to 0, that means they are divisible. So we want to find the largest subset that every pair in the subset are divisible. For example, 1, 2, 3, right? So 1, 2, or 1, 3, they are both divisible. So we want to find any of the subset, return a list of integer. And also 1, 2, 4, 8, you see any of the two that will be divisible, right? So we return 1, 2, 4, 8. So for this question, we're thinking about if we have nums I, right, and nums j. And if we have num j mod divisible by nums I, right? If we have this kind of scenario, we know for example, nums I smaller equal to nums j, right? And if we have nums k, if num k divisible by nums j, right? So we'll say nums j smaller equals to nums k, right? In this, if we have these two conditions, we'll say nums k will be divisible by nums I, right? For example, we have 1, 2, right? 2 is divisible by 1. And if we have any other numbers, for example, 6, right? 6 is divisible by 2. Then 6 is, of course, divisible by 1, right? So intuitively, what we're thinking about is that we can sort these nums to have some kind of ascending order, right? And for every number, we want to find the for example, we have every number, right? We can count what's the maximal divisible length to this number. For example, we have A0 to AI, right? So for this one, if we have found a sequence previous to that, which is for example, a length, right? And we iterate to the right. And for example, we until we go to a n minus 1, right? And everyone will have an largest set length to this number, right? So we can create something called int dp, right? So that one is the largest subset end with this number, right? So every dpi, it will determine from any of the previous divisible number plus 1, right? So will be max dpj plus 1, right? And for this kind of dpj, we need to have to the nums I mod nums j equals to 0, right? Means it's divisible by j. And in this case, we'll have get a result called int dp, right? And we find the maximal dp we can get its length. So the max length, max size of subset will be the max number of this dp, right? So if we already have this dp number array calculate, how can we get the find one of the largest subset, right? So what we do is that we from the one which is the max in this array, right? And we for example, this is I. We trying to iterate to index to the previous one, right? And if we have, for example, have an index, we have the nums I mod, for example, we have another index mod j, nums j equals to 0, and also the dpj plus 1 equals dpi, right? Then we can add this kind of, means this kind of number and our nums I, nums j, that will form a sequence. And from the max, all right, we just compose one of the sequence. And if we find one, we just break, right? And we add that to list. And we reverse the list, we'll get the final result. So let's begin to write code for this, right? So we'll say, because we'll say we want the larger number, right? So we need to sort, right? Because if as we say, if there is nums k divisible by nums j and nums j divisible by nums I, well, of course, say nums k will divisible by nums I. So intuitively, we think about is that we sort these arrays. This arrays sort nums, right? And the sort will be n log n, right? But we calculate the max divisible set size, that will be n squared, right? So the sort will not get our time complexity worse. So we'll have int n equals nums dot length, right? And we'll have, let's have this dp equals new int. Let's have the same size with the num size. Let's have arrays fill this DPS1, right? Because every number can have one set of itself. So let's begin to calculate the longest set end with this number, so that we'll have int I equals 1, I smaller than n, I plus plus. So we'll have for int j equals to 0, right? J is smaller than I, j plus plus. dp I. The sense that if it is divisible, right? If nums I mod nums j equals to 0, then we'll have dp I equals max dot max dp I and dp j plus 1, right? Now let's try to find we get the dp array, right? Means the largest set end with this nums I. So we try to compose. Let's find the index which has the largest one, right? So let's have int max equals 0. Actually, we can set it as 1, right? Because everyone will have 1, right? And index equal to 0. Say for int I equals 0, I smaller than n, I plus plus. If dp I greater than max, right? I have index equals I, then the max equals dpi, right? So in this case, we find the max. We start from this one, right? It has a max subset, right? And what we are going to do is we are going to create the result. So list integer result equals new array list. So we'll have int I equals index, and let's add this one. Add nums. And we can say while this DPI greater than 1, right? What we are going to do is that we are trying to find the index previous to I, right? Int j equals I plus 1, j greater equal to 0, j minus minus. And if we have nums I more divisible by nums j equals to 0, and we'll make sure this one is just smaller, right? Just one smaller than this. That means this these nums I can come from this nums j, right? Then we are going to add this nums j, right? And actually, for this case, we can set I equals j and a break, right? And after this one, we'll see this result is in a reverse order, right? We should reverse it. Reverse result, right? In the end, we just return result. So here, to calculate the max length, right? This is O(n) squared. Sort is n log n, right? And this is O(n), find the max one, and we trying to iterate from the max to the previous one, right? So this is O(n), and this is reverse, right? So this time complexity will be O(n) squared. Let's also write this code into Python, right? So these nums we also need a sort, right? Nums sort, and let's have I equals this length, and we have DP, right? DP is an array set the initial every number that will be 1, right? So let's have this. So what we do is that for I in range 1 and n, right? And we'll say for j in range from 0 to I, right? So that will be I. I'll say if nums I mod nums j equals to 0, right? We'll have dp I equals max, right? Just max dp I dp j plus 1, right? So this is the steps to create the dp array, which means the max size, and with the index I, what's the max size to this number I. So we'll have a number. Let's have called max dp equals max dp, right? This will be our max size. And we'll define for example, index, right? Index will be our DP max DP, okay. And what else? We need to have the result, right? We have the result. Result, it will also be a list, right? And this list, initially we need to find, put the nums index in it, right? So what we do is that while this max DP greater than 1, right? We'll do for let's have for J in range index -1. Greater equal to 0, right? So you have -1, and in a reversed order -1, right? We'll say if nums index mod nums j equals to 0, we'll say and the dp is just one less, right? dp j equals max dp -1, right? Let's call it length, right? Because this will be changed. So we'll say size, okay? Size. Initially, that will be our max DP, right? So size -1. Our result will append nums G, right? And we'll have our index equals G, right? And we'll have our size minus equal to 1. And we need to break this for loop, right? Break. And in the end, we need to reverse our results, right? Just return result this. If nums index model and this one equals size. This index, we need to find for this value what is index of it. So in Python, it has dp index max dp size, right? Have this function to get the index of the value to be size, right? So call it dp index, okay? dp index size not accessible with a value. Let's set it into multiple lines. Let's say this size equals max dp, and we'll have index equals dp index size, and we'll have result equals norms index.